Good morning and welcome to good afternoon, whatever. Good to have you here. We're gonna have another quick video, but before we go, joke. What did the knock knock joke win? A Nobel Peace Prize. Nobel is knock knock. Okay. Okay. You guys seriously love this stuff, don't you? Okay. So we're still doing continuous distribution probabilities. And we are still talking about general normal distributions. So we've talked about normal distributions and it's more or less the same. And it's basically the thing that you need to get down pat is you need to understand how the mean, standard deviation, and z-scores, how they kind of like play with one another and how it kind of all reacts to the bell curve. So I guess really quickly, just remember your z-score is given by your score, take away your mean, all over your standard deviation. And then also the way that your bell curves work is you're going to have a bell curve, and in your center, we're talking about your z-scores. That's a z-score of 0. And then you're going to have between, I guess, -1 and 1 z-score. We're going to have between -2, -3, -2, -3. Okay, 2, 3, -2, -3. And those are all your z-scores. And just a quick little reminder that there is 68%, between -2 and 2 is 95%, and between -3 and 3 is 99.7%. Okay, now let's jump straight to some questions that they'll ask. They'll say a data set has a mean, and sometimes they'll do X with a hat, or it could also be, there's a lot of different ways that they write this stuff. So it could be mu, it could be X with a line on top, X bar. And so basically has a mean of 6 and a standard deviation S, or sometimes they'll have that little thing of 1.5. So it says find the scores 1, 2, and 3 standard deviations from the mean. So very, very simply is if I wanted to, it would just be 6 plus, and then if I'm going 1 standard deviation above the mean, it's going to be 6 plus 1.5, which is 7.5. Or this is a z-score of 1. If I have a z-score of -1, it's going to be 6 minus 1.5, which is 4.5. Okay, for z, if my z-score equals to 2, I'm gonna start with my mean, but I'm gonna plus 2 lots of my standard deviation. So in this case, my standard deviation is 3. So that's going to be a score of 9. But if I had a z-score of -2, I'm gonna start with 6, but I'm gonna go down to -3. That's a score of 3. And I hope you get the same idea for if we wanted 3 standard deviations up or down from the mean. Okay, now z-scores, that's what it is. A z-score is just a measure from how many standard deviations you are away from the mean. So the smaller the number, the closer you are to the average. Right? If you're positive, that means you're way ahead. If you're negative, that means you're behind the average or behind the mean. Okay, now working backwards, very, very similarly, is how many standard deviations are the scores 7.2, 5.5, and 2.5 from the mean. So if they're a little bit harder to read or to, I guess, kind of think in your head, the best way to do this is to use your z-score. So your z-score here for 7.2 is that's going to be your score. Take away your mean, which we found out was 6, all over your standard deviation, which was 1.5. So that's for 7.2. Right, if I had x equals to 5.5, I'd have a z-score of 5.5, take away 6 over 1.5. And then same thing for if x equals to 2.5, it's going to be, your z-score is going to be 2.5, take away 6, all over 1.5. And again, you can put these in your calculator, but I think you guys can do that on your own. The value that it would give you is, remember, if your z-scores are positive, that means you're above average. If your z-scores are negative, that means you're below the average. Okay. So I guess for 5.5 and 2.5, we're expecting a negative Z score, whereas 7.2 is above 6, so we're expecting that to be above. Okay, now this is probably the main one. So all these ones are just kind of talking about the scores, talking about the standard deviations, but where it starts to get practical is find the probability, all right, that a score is less than or equal to 4.5. Now, I picked these ones here because I wanted to show you that for all your probability questions, it's often helpful to actually draw out your probability curve, right? Your normal distribution curve. Now, we know that we have, I'm going to do 2 layers here. So one of them will be the scores, and then the other one will be the Z scores. So we know we've got 0, and pretending that I did these evenly, I'm just going to go from -2 to 2 because I don't think we'll need 3 for this question. And of course, I would write 3. Now, in the middle is your mean. So that means the mean of this data set we read from all the way up here, the mean was 6, right? And we also had a standard deviation of 1.5. So let's start there. That means your score, a Z score of 0 would mean a normal score of 6. And a Z score of 1 would be +1 standard deviation. Now it's going to be 7.5. For 2, it would be 9. Okay, now also going backwards, if I minus 1.5, that means a Z score of -1 gives me a score of 4.5. And then for -2, it will be a Z score of -3 in this case. Oops, not -3, just 3. Okay, so hopefully you can see how the Z scores and the actual scores kind of relate, how they interact with one another and how that kind of messes with the curve. Now, if I want the probability that X is less than 4.5, that means I'm looking out for all this area here. Okay, so I would shade it in, and I would do this in all your questions as well. Now, to figure this out between here and here, from the midway point, I know that that's 50%. Okay, now the other thing that I know, and this is where you're going to have to start to do a bit of thinking, I know that between -1 and 1 Z score, I know that's 68%. So I mean, I know in between here, that's going to be 34%. Okay, so by looking at this now, I can see that this area here is just, well, I guess all this area here is going to be 50%, take away the 34% that's within 1 standard deviation. So in other words, this one here, for C, probability that my score is less than or equal to 4.5, it's going to be 50, take away 34, and that's going to give me, if my math is correct, 26%. That's my probability that I pick a score less than 4.5. Okay, now for the next one, I chose this one particularly as well, that it's greater than or equal to 7.5. So this is my 7.5, and that means I'm looking for anything that's over 1 standard deviation. So if you notice here, I know I haven't drawn it perfectly, but they should be the same either side because it's a symmetrical normal curve. That's what a bell curve is. It's symmetrical. So in other words, for D, it should also just be the same thing, right? It should just equal to 26%. Don't need to show my working out again. And you can say that this is because it's symmetrical. Okay, no need to do your working out all over again because you already did it for part C. Okay, hopefully that's making a bit of sense. And yeah, hopefully that helps. And I'll catch you guys later. See you in the next video. Alrighty, bye-bye.